All right, so we're going to talk about handout 18C now. And 18C is going to talk about hormonal control. And the first thing that we're going to talk about are hormone interactions. And there's three categories. We can be permissive, synergistic, or antagonistic. Permissive hormones are two different hormones that help each other. So it just says one hormone strengthens the effect of another. My example here is something that we haven't really talked about, but thyroid hormones can strengthen epinephrine hormones' effect on lipolysis, breaking down fat. So we have two unrelated hormones that are going to be helping one another. They strengthen the effect. Synergistic hormones are two hormones acting together for a greater effect. And so this example would be like estrogen and luteinizing hormone that are working to develop our egg, our oocyte. So this is what we call a synergistic relationship. Now, another example of this would be something like the two thyroid hormones, T3 and T4, they're synergistic. Epinephrine and norepinephrine, they're working together for a greater effect. So, adrenaline isn't just epinephrine, it's epinephrine and norepinephrine. And so it's kind of wrong just to say epinephrine's adrenaline, but they are synergistic. Another example would be estrogen by itself. We shouldn't actually say estrogen. We should say estrogens, because there's actually more than one type of estrogen hormone that really does the same thing. So they help each other for the greater effect. Now we have antagonistic hormones as well. And these are obviously two hormones that are doing the opposite job. And I have two examples here. The first one is insulin and glucagon. If you remember, insulin grabs glucose out of our blood and delivers it to our body, whereas glucagon takes glycogen and turns it back into glucose. So insulin lowers our blood sugar by taking the sugar out of our blood, whereas glucagon is adding sugar to our blood. Another example is a pair of hormones that we talked about first semester. One of them was calcitonin. The other one was parathyroid hormone. And remember, go back in your notes and look at this, but they are regulating calcium. So calcitonin actually takes calcium out of your blood by stimulating osteoblast cells, and parathyroid hormone adds calcium back to your blood by using osteoclasts. And we'll probably talk about this a little bit later on in this chapter too, to remind you. But these are just hormone interactions. All right, let's slide down to hormone secretions. And hormone secretions, we regulate our hormones via secretion. So the secreting hormone we're going to regulate through the nervous system. So we can signal a hormone to be secreted and released by the nervous system. Regulation can also cause blood chemistry. So we can have chemicals that stimulate the hormone, and our blood chemistry can dictate that. That's how we regulate it. So if we have too much of a hormone in the bloodstream, we might shut it off, or if we have too little, we might turn it on. And then we have other hormones, of course. We've talked about this a lot, where we have one hormone activating another hormone, activating another hormone. So it's just that these hormones are stimulating each other. So remember, the hypothalamus makes these releasing hormones, and these releasing hormones tell the pituitary to produce a hormone that goes and does something. So, the one that just pops in my head is prolactin. So we have prolactin releasing hormone in the hypothalamus that tells the pituitary gland to release prolactin, and then prolactin goes through our bloodstream to produce milk. That is a good example of how more than one hormone can activate others. All right. And it says most regulation is going to be a negative feedback. Remember, almost everything we talk about in class are negative feedbacks. Now, there are a few good positive feedbacks that lead us away from homeostasis, like oxytocin for childbirth or prolactin for milk production. But most of our regulation's going to be through a negative feedback to keep us in homeostasis, right? Okay, so that takes care of handout C. Let's move on to handout D.